So today we're going to prepare you for your Unit 3 quiz. So we're just going to run through all the targets here. On your first target, remember it gives you a point, x, y, and you're going to have to determine if it's a solution to this system. So we do that by plugging in the x value and the y value into both the equations. So starting with the top equation, if I do 4 plus 2 times negative 1, does that equal 1? So 4 minus 2 does not equal 1. So no, this is not a solution to that system. Remember, it has to be true in both equations. So doing the same thing over here, just new numbers, plugging in 2 for x and then 1 for y. It's true in that top equation. So let's see if it's true in the second equation. 3 times 2 minus 1, that does equal 5. So since it's true in both equations, yes, that is the solution to that system. Target 2, we were solving by graphing. So on A, those equations are both in slope-intercept form, so I'm going to go straight into graphing. That top equation has a y-intercept of -1. Oops. Let's get that to be a little bit more exact. And a slope of -1. So we're going to go down 1 over 1. And if you remember, we try to make these as exact as possible just because we need to find that exact point of intersection. So I'm going to stop there and see how that works once I graph the second line. And so for the second line, x minus 9, so I'm going to start at -9 with a slope of 1. And I can see that point of intersection really clearly because I made the point so, I made so many points. So that point is 4, -5. Remember, you can still check your answers like you did on the top target on target 1. So on B, I'm going to have to put these equations in slope-intercept form first. So in the top equation, I'm going to go ahead and subtract by x and then divide by -1. So I have a y-intercept of -7 and a slope of 1. So there's my first line. And then my second line, I'm going to subtract 2x. So that means I'm going to start up here at 5 with a slope of -2. And I can see where that crashes into this first line. And that value is at 4, -3. So on the next target, on the second page, we're going to do the same thing, but we're going to do this algebraically. So starting with substitution. For substitution, we have to get one of our equations equal to a variable. So I'm going to use this top equation. It doesn't matter how you do this. And I'm going to add y over. So it reads x equals y plus 7. And then I'm going to take y plus 7 and I'm going to plug it in for x in the second equation. So the second equation would read 2 times y plus 7 plus y equals 5. And then I'm going to distribute the 2. So 2y plus 14 plus y equals 5. Combining like terms, I get 3y plus 14 equals 5. And then I'm going to subtract 14 from both sides, so I get 3y equals -9. So y must equal -3. Once you have your first variable, then we're going to plug that back in. So I'm going to plug it back into this equation right here. So x equals -3 plus 7. So x equals 4. So your solution is 4, -3. Same method here on B. I'm going to choose this top equation and I'm going to solve it for y. So if I subtract the 3x over, I get -y equals -3x plus 4. And then I have to divide by a -1 to get y by itself. And then I can take 3x minus 4 and plug it in for y in the second equation. So it would read 2x plus 3 times 3x minus 4 equals 32. And then I'm distributing that 3 and then combining like terms. So 2x plus 9x is 11x. If I add the 12 over, I get 44. Dividing by 11, I get x equals 4. I'm going to plug that back in. You can plug it back in anywhere. I'm going to plug it back into this equation. So y equals 3 times 4, because that's what x is, minus 4. So y equals 12 minus 4, which means y equals 8. So my solution here would be 4, 8. So solving our systems one more way by elimination. This is where we multiply one or both your equations by something so that when we add, they will cancel out. The variables would cancel out. So looking at the x's here on A, I'm recognizing if I multiply the top equation by 2, that would give me a negative 6x, which would cancel out with the positive 6x. So multiplying that whole equation by 2, adding these two together, the x's cancel out, but now I'm also noticing that the y's cancel out. So I get 0 equals negative 14, which is a false statement. So that means these lines are parallel. There's no solution. Remember, if that was a true statement, that would be infinite solutions. On B, you can either work to get x or y to cancel out. I'm going to work with y just because I worked with x last time. So I have 2y and 5y. I can get both of those to a 10. So I'm going to multiply this top equation by negative 5. And the reason I'm choosing negative 5 is so this one will be a negative 10. 27 times negative 5 gives me negative 135. And then I'm going to multiply this one by 3. So that's oh, sorry, by 2. That was my fault. I got 15 stuck in my head for some reason. So if I multiply that bottom equation by 2, that would be a negative 8x plus 10y. So that's a positive 10y, which cancels out with the negative 10y above. And then that would be minus 72. So the 10s cancel out, and that would be negative 23x equals negative 72, negative 207. And if I divide both sides by negative 23, I get x equals 9. I'm going to plug that back into the bottom equation. So negative 4 times 9 plus 5y equals negative 36. So that is negative 36. And if I add the negative 36 over, I get 5y equals 0. So y equals 0. So my solution here is 9, 0. And when you're taking your quiz, again, I would recommend plugging that back in for x and y, and you should get a true statement in both your equations. All right, so target 5, we are writing and solving our system of linear equations. So we have a concession stand. So John went to the concession stand. He bought some hot dogs and pretzels. The hot dogs were $1.50, pretzels were $1. He bought 2 more pretzels than hot dogs, and his total was $7. So we've got to declare our variables first. So I'm going to use D for hot dogs and P for pretzels. And then we're going to write our equation. So our first equation talks about worth. So how much is a hot dog worth? It's worth $1.50. How much is a pretzel worth? It's worth $1. So just 1p, or we could just write p, equals money plus money should equal total money, so it equals $7. Then it also talks about how much. He bought 2 more pretzels than hot dogs. So what did he buy more of? He had more pretzels. So we're going to do P equals, and then it says 2 more, which would be plus 2. So dogs plus 2. So here's our system. And then we have to solve it. Since the second equation says P equals, I'm going to use substitution. I'm going to plug this in for P. So that it's 150 D plus and plugging in for P, that would be D plus 2 equals, I'm just going to say 7 instead of $7. So if I add together the 2 hot dogs, that would be 2.5 plus 2 equals 7, subtracting 2. Oop, I lost the D. So 2.5 D subtracting 2 equals 5. And if I divide both sides by 2.5, I get D equals 2. And then we can plug that back in maybe to this equation. And P equals 2 plus 2, which is 4. So then let's go ahead and write out our answer. There were 2 hot dogs purchased and 2 pretzels. Oh, sorry, 4 pretzels. Goodness. And that would be my final answer. So same thing, just different situation here on B. We have an 8-day trip to Canada. It's going to cost $300 for a day in Montreal, $500 for a day in Ontario. We have our total budget, and then we're going to declare our variables to start with. So I'm going to say M is Montreal, and I'm going to say N is Ontario. I don't like to use O because it just looks like a 0 in my work. So our first equation deals with worth. How much is a day in Montreal worth? It's worth $300. It told us that. A day in Ontario is worth $500. Money plus money should equal total money, so equals $3,000. The only piece of information we haven't used yet is the fact this is an 8-day trip. So that's a total. So when we add together Montreal plus Ontario, it should equal 8 total. This is our system. Now we're going to solve it. I'm going to choose to multiply this bottom equation by negative 300. So that gives me negative 300m minus 300n equals negative 2400. And now I'm going to add it together with this top line. So the m's cancel out. For the n's, we have 500 minus 300, so a total of 200. And then I have 3,000 minus 2,400, which is 600, which means n is 3. If n is 3, Ontario is 3, and it was an 8-day trip, m plus 3 equals 8. That means m has to be 5. So it was 5 days in Montreal and 3 days in Ontario. And then for target 6, the first thing we're going to do is determine if the point is a solution. So starting with A, we're going to plug in x and y. So that would be 2 times 4 minus 0 is greater than 3, which is a true statement. 8 is greater than 3. And then for this bottom one, if I plug in x and y, I get 4 plus 0 is less than or equal to negative 6. 4 is not less than or equal to negative 6, so since it's false in the second statement, that's overall a no. In B, so same idea, just different numbers. So 3 times negative 3, I'm plugging in the point for x and y, plus 5 times negative 6, is that greater than negative 30? So that would be negative 39 is greater than negative 30. That is a false statement, so no, that is not a solution. So then we're going to look at this graphically. So let's look at the point 6, 9. 6, 9 is right here. That is not a point that is in the double shaded region. That's what we're looking for. For negative 2, 0, if you look at that, it borders the double shaded region, but it's on a dotted line. So this is not a solution. So anything within this region would be a solution, and anything that's on the border on the solid line would also be a solution, but those were not. And for our last target here, we're going to graph our linear inequalities. So let's start with our top equation. So y is less than negative 5x plus 3. So here's 3. And then we have a slope of negative 5. And then this is going to be a dotted line. Don't forget that step, that it has to be dotted because it's not equal to. For the shading, it says y is less than, so we're going to shade under this line. And then for the second equation, it says y is less than negative 6. So we're going to graph negative 6 as a solid line. It's a horizontal line, and it says less than, so we're going to shade below. And our final answer here is that double shaded region. So if you can't tell where that is, it's right in here. And then for your last one, y is greater than or equal to negative 1/2 x minus 5. So I'm going to start at negative 5 with a slope of negative 1/2. And that is equal to, so I'm going to go ahead and create a solid line. And since it says y is greater than, I'm going to shade above. For the second inequality, that has a y-intercept of 7 and a slope of 2. Remember, I'm not interested in the point of intersection on this one. Last time when we graphed it, we're looking for the point of intersection, not the case here. That's also equal to, so it's also going to be a solid line. And it says y is less than, so I'm going to shade below that line. And while I'm doing that, I'm looking for that double shaded region. That's going to be our solution. So anything that falls within this region, any point that falls within this region is going to be a solution to that system.